Hello everyone, thank you for joining our webinar today. I hope you're having a great day. I am Ishwar, a product expert at Analytics Plus, Manage Engine's flagship IT analytics solution, and I am excited to conduct this highly anticipated and informative session. As you already know, today we'll be discussing analytics-powered strategies to minimize downtime and streamline IT operations. So before we begin, a few housekeeping notes. By default, all attendees will be on listen-only mode. If you have any questions during the webinar, feel free to type them in chat or drop them in the Q&A panel on the left side of the screen. I'll try my best to get to them towards the end of the session. In case we run short on time, I'll respond to your questions later via email. You're also welcome to email me your questions directly using the address shown on your screen. With that, let's get started with the webinar. Outages are a major headache plaguing NOC teams on a regular basis. They are a constant source of frustration that gnaws away at the productivity, revenue, and reputation of IT teams with ripple effects that permeate every corner of the organization. According to a study conducted by global research firm Dun & Bradstreet, a staggering 59% of Fortune 500 companies grapple with nearly 2 hours of unplanned IT downtime per week. This statistic rings alarm bells for enterprises worldwide, especially when considering the mind-numbing cost of IT downtime, which is estimated to exceed $400,000 per hour across sectors. So, the primary mission of any NOC team is to cultivate a reliable IT operations landscape, one that offers optimal service availability and reliability without sacrificing on performance. However, in today's modern, evolving, and highly complex IT infrastructure, achieving this goal is easier said than done. To realize this vision of an efficient NOC team that works like a well-oiled machine, the key lies in proactively identifying indicators of downtime and implementing strategies to mitigate their impact, ensuring maximum uptime for critical infrastructure components. One crucial aspect in this endeavor is tackling key incident or failure metrics that lies at the heart of IT operations, such as mean time between failures, or MTBF. By dissecting these metrics, you can pinpoint weak links in your IT infrastructure and deploy proactive measures to address them. This not only reduces the frequency of downtime, but also minimizes its impacts on critical business parameters. In today's session, we'll delve into 3 quick yet proven strategies that you can implement to curb IT downtime and foster seamless operational efficiency within your organization. So without further ado, let's dive right in and explore how you can safeguard your IT landscape against the scourge of IT downtime. So moving to the step 1 of our 3-step strategy, which is implementing preventive maintenance strategies across infrastructure lifecycle. Robust preventive maintenance strategies form the most powerful weapon in arsenal of any NOC team against unplanned downtime. By implementing scheduled maintenance routines and timely inspections, organizations can identify and address potential issues before they escalate into critical failures that cause downtime, safeguarding the reliability and performance of their IT infrastructure. Preventive maintenance generally comprises of an array of pre-planned activities like checks, updates, improvements, fixes, etc. that helps promptly detect and resolve potential issues in your IT infrastructure. By adhering to a structured preventive maintenance strategy, IT teams can minimize the risk of unexpected downtime, optimize IT operations, and extend the lifespan of critical infrastructure components. Let's now look at 3 ways in which AI-powered IT analytics can help you plan, implement, analyze, and fine-tune tailored preventive maintenance strategies to fortify your IT infrastructure against the threat of unplanned downtime. The preventive maintenance approach that I am going to talk about first is analyzing the historical data to streamline future plans. So analyzing historical trends and frequency of breakages allows you to identify patterns and trends that can provide valuable insights, such as common failure points and recurring maintenance issues within resources that are currently deployed in your IT infrastructure. By viewing this information from both a product type and a vendor perspective, you can form the foundation for a robust preventive maintenance strategy. With Analytics Plus, ManageEngine's flagship IT analytics tool, building this type of analysis is a straightforward process. I'll walk you through the various capabilities of Analytics Plus as your ideal IT analytics partner in more detail soon, but for now, let's focus on the topic at hand. The analysis projected on your screen illustrates the average frequency of downtime incidents over a period of 6 years for 10 high-impact devices that belong to corporate HQ's IT infrastructure. Through careful analysis of this visualization, you can quickly identify any noticeable trends in frequency of downtime for specific devices since they were purchased, which helps you in determining their optimal maintenance intervals. For example, the analysis shows a sharp increase in downtime incident frequency for Apache Tomcat server post year 2022, approximately 4 years since its purchase. The analysis also pinpoints inconsistent availability for Docker container and consistent breach of downtime frequency thresholds by TP-Link switch. These observations highlight the need to revisit maintenance plans for devices such as Apache Tomcat server, Docker container, and TP-Link switch. So we have seen the challenge there. How do we address this issue? To address such issues proactively, in future, for Apache servers, consider increasing the frequency of maintenance activities after 4 years. Similarly, the overall maintenance schedule for Docker containers and TP-Links need to be revisited to maximize mean time between failures, or MTBF, and increase the lifespan of these assets. Now, while I was going through the above strategy, at least some of you might have wondered, this approach can work for devices or device types that are already in use or part of my existing infrastructure. However, what about onboarding new devices that have never been deployed in my previously in my organization? How do we establish a foolproof maintenance schedule during installation or onboarding of completely new resources while performing upgrades to your existing infrastructure? Well, these are valid questions that need to be addressed. In the realm of IT resource procurement, not all vendors or products are cut from the same cloth. It is your responsibility to separate the diamond from the rough, put reliability as well as durability at the forefront, and make choices that shape the future of your IT infrastructure. By incorporating vendor and product performance data into your procurement plans, organizations like yours can make informed choices that align with your maintenance and service availability objectives. The analysis projected on your screen showcases the average expected lifespan of assets and compares it to the proportion covered by manufacturer's warranty. By choosing resources or assets with longer lifespans, organizations can minimize the frequency of replacements and hence the associated downtimes. NOC teams can get an idea of product's lifespan by carefully analyzing one or more aspects among manufacturer specification, industry standards and benchmark, your IT domain knowledge, and expert consultation with people who are subject matter experts in IT and IT ops domain. Now let's switch back to the analysis. Assets with comprehensive warranty coverage and extended support options are better equipped to address potential issues promptly, reducing downtime. It is therefore a good practice to prioritize vendors or products with longer warranty periods and comprehensive coverage options, ensuring reduced financial impact in case of critical failures. However, the key metric we need to track is the average time required to repair failures. By comparing the average time taken to resolve the outages arising from different vendors, NOC teams can quickly identify vendors that provide better returns in terms of increased performance and product reliability. Now let's move to the second approach towards proactive maintenance to reduce IT downtime. In the previous step, we had taken necessary precautions that streamline device purchase and deployment phase to avoid downtime as well as increase the total usable life of assets. Now we need to focus on streamlining the day-to-day operations post-deployment to catch any signs of failure in advance and mitigate them promptly. Tracking and logging of performance and availability of all resources that are part of an organization's IT infrastructure is the primary responsibility of NOC teams. However, as we have touched upon earlier, the modern enterprise IT operation landscape is highly complex, comprising of multiple moving parts spread across an organization's IT, and they come with their parameters and monitoring applications that need to be kept track of. So getting visibility into all these signs, issues, and bottlenecks across your complex IT landscape and correlating them to preempt potential faults can prove impossible, making the life of a NOC personnel a living hell. Therefore, the priority of the hour is to create a single source of truth that can bring together insights from multiple sources and applications into a single window, making it easy for NOC teams to regularly keep tabs on end-to-end IT infrastructure, identifying error-prone avenues, anomalies, or patterns that can lead to potential downtime. Once such a consolidated and extensive dashboard is set up, it makes it easier for technicians to promptly detect and triage the cause whenever a fault occurs or resource goes down. The dashboard that's shown on your screen helps you track several critical infrastructure, availability, and performance parameters from several sources spread across the key components of an organization's IT infrastructure. This includes networks, applications, cloud resources, and more. For the purpose of this webinar, let's look at network and application dashboards. But you can configure more components and fine-tune this based on your organizational needs. So when it comes to the network side of things, the real-time tracking of network throughput as well as volume of traffic flowing in and out of the network can help NOC teams quickly identify any component failures or security breaches. Unusual spikes in traffic flow or throughput errors may indicate an issue that could eventually lead to network downtime. So proactive detection allows NOC teams to address these problems before they escalate. Packet loss is another critical performance indicator that can signal an impending network outage. As packet loss rises, it severely degrades the speed and functionality of network operations like downloads, uploads, and more. Consistently high packet loss, that is somewhere in the range of 5 to 20%, is a serious concern and an early warning that networks may fail within hours, if not minutes. So moving from network to the application side, one of the most common causes of downtime or outage in an application is resource overutilization, leading to capacity overload. By tracking usage metrics like CPU and memory utilization, organizations can identify applications approaching resource overload. Armed with this insight, NOC leaders can proactively plan resource utilization, procure additional capacity, or reallocate their applications' workloads from resources approaching their capacity limits. This helps prevent overloads that degrade application performance and results in outages or downtimes in the long run. And coming to application response times, slow application response time can severely impact user experience. By closely monitoring hourly response time trends as shown in the report, NOC teams can quickly identify underperforming applications with high load times. This allows NOC teams to rapidly evaluate their infrastructure, pinpoint root causes, and address issues before they escalate into larger problems that can lead to application downtime. So, as we have seen, tracking such critical infrastructure KPIs in a single unified dashboard can prove useful in identifying hardware or software failures that eventually result in an outage. Through this manner of analysis, you can get an idea of your infrastructure's current health status and identify when outages are going to occur. And then you can come up with a structured maintenance plan to prevent these outages in advance before they hit the components and cause trouble. Now let's move to the third and final approach towards preventive maintenance, which is analyzing the impact of preventive maintenance for constant improvement. So, as we have seen in the past two approaches, we have implemented preventive maintenance strategies to combat IT downtimes. So, before we move on to the next step of our three-step approach, we must assess whether the configured preventive maintenance strategies are delivering the intended operational improvements to our IT. By analyzing the impact of preventive maintenance initiatives on key maintenance indicators like mean time between failures, mean time to repair, and downtime, we can measure the effectiveness of these strategies and course correct as required. Let us consider the case of an organization that has realized the importance of preventive maintenance strategies and has established these strategies in the quarter 4 of 2023, that is the fourth quarter of year 2023. Now, let's go back to our Analytics Plus workspace and analyze the impact of these preventive maintenance strategies implemented on the first quarter of 2024 and beyond. By observing the analysis on your screen, you can see that robust preventive maintenance practices have reduced the number of unexpected failures per month, resulting in a more stable environment and reducing the need for reactive interventions over time. The preventive maintenance approach also enables IT teams to minimize the time interval between disruptions, reducing the time to restore normal operations post-disruption and maintaining high productivity levels. We can actually use the power of predictive analytics to identify how this impact will sustain going forward and help streamline and enhance the performance as well as availability of your IT infrastructure. So the predictive analytics for the next 3 months is represented as a dotted line in the analysis. So overall, this analysis does play a vital role in tracking the performance of scheduled maintenance, allowing NOC teams to continually course correct strategies in a manner that keeps up with changing organizational requirements and ensures maximum resource availability. So with that, let's move on to the second step of our three-step strategy to prevent the impact of IT downtime. So until now, we looked at several preventive maintenance measures that can be used to reduce the frequency of unplanned downtime. Let's now shift our focus to identifying how faulty hardware in your organization's infrastructure can impact downtimes and how you can implement investigative techniques to address these underlying inefficiencies and reduce downtime as well as maintain operational reliability. Hardware failures often serve as primary culprits behind IT downtime in enterprises, impacting the NOC team's productivity and operational efficiency. It also tends to be more resource draining and time-consuming root cause that drains an organization's IT budget. Devices that constantly encounter faults or failures can disrupt daily operations significantly, leading to serious business repercussions. In this section, we will delve deep into how you can effectively employ data and IT analytics to streamline inventory management process and strategically remove devices that contribute to frequent downtime across the organization. This analysis shows the number of failure alarms in a given month for different devices within an organization's IT infrastructure. Devices with high failure rates are identified as potential candidates for causing frequent downtime, warranting further investigations and proactive measures. A crucial aspect of this analysis again is the mean time to repair or MTTR values, which provides insights into the time required by NOC technicians to resolve faults across individual devices. Devices with consistently high MTTR values are at the core of longer downtime issues in an organization. The analysis also highlights significant portion of alerts resulting from incidents recurring from past months, indicating inefficient troubleshooting practices and a failure to address an outage's root cause, ultimately leading to lower MTBF values and reduced service availability. So overall, this visualization isolates problematic assets and ensures that you triage the root cause as well as take proactive measures to prevent downtime due to failures of such devices. So to effectively minimize the downtime caused by faulty hardware, there are several proactive strategies that organizations can implement. And I have listed them here. First one is extensive troubleshooting and maintenance practices. Emphasize and enforce the importance of thorough identification and mitigation of root causes over quick temporary fixes, reducing the likelihood of repeated and frequent failures. Next is implementing automated anomaly detection. Here, you need to configure automated alerts to detect symptoms of failures in real time and notify the respective NOC technicians to orchestrate swift remediation actions. The next step is ensuring patch compliance. Regularly update patches and software fixes to maintain system integrity and reliability. From this, we move on to streamlining the maintenance cycles. Here, implementing a proactive maintenance schedule with shorter and more frequent cycles to preemptively address potential hardware issues can go a long way in combating faulty asset-related IT downtimes. And finally, timely replacements of aging devices. We have to proactively replace problematic or aging devices reaching the end of their life cycle to prevent prolonged downtime and maintenance charges. So in conclusion, by leveraging analytics to identify and eliminate devices contributing to frequent downtime and implementing proactive strategies to mitigate hardware-related issues, organizations can significantly diminish the impact of IT downtime on their daily operation. And with that, let's move to the third and the final step in our three-step downtime reduction strategy. The step 3 of our downtime reduction strategy involves identifying patterns in alarms. Modern-day IT operations generate a deluge of alarms on a daily basis from various components, tools, and services deployed and monitored across an organization's IT infrastructure. These alarms are indicators of several issues that can blow up and cause show-stopping business disruptions if not attended in a timely manner. So being part of an NOC team is like sitting on a time bomb that can explode at any moment. This alarm-centric nature of modern NOC landscape can be a major cause of concern when it comes to resolution time, because the most critical and high-impact alarms are often drowned by a barrage of irrelevant alerts. NOC teams across enterprises have to deal with often irrelevant alarms that are caused by factors like repetitive alerts for the same underlying problem, expected breaches that are part of the natural course of operations, and redundant as well as false alarms caused by outdated thresholds. NOC teams often lose valuable time in distinguishing these non-critical alarms from critical and high-impact ones. This can lead to huge delays for teams in attending and mitigating such critical faults, leading to a storm of costly outages and downtimes. The solution to this problem can be found through analytics. Now, let's look at how NOC personnel can leverage the power of AI-powered analytics to fight the issue of redundant alarms that result in increased downtime. Let's first explore the case of repetitive alerts, a common thorn in the side of NOC teams worldwide. These persistent alerts often stem from unresolved root causes that permeate multiple layers of your IT infrastructure. Not only do they distract the IT personnel, but they also impede the resolution process, leading to prolonged downtime and loss in productivity. With the help of AI-powered analytics, NOC teams can unearth patterns within alarms, enabling them to correlate and merge alerts that share a common underlying issue. This reduces the alarm clutter and streamlines the fault identification as well as the triaging process, paving way for more efficient and effective resolution workflow. Let's see this in action. As shown in this analysis, visualizing alarms collectively helps identify patterns within them. So the analysis actually categorizes the total number of alarms that was triggered in year 2023 on the basis of month as well as application type. You can see that in the months of February as well as October, there is a common uncharacteristic spike in alarm generated across all resources. While when you take the case of the month of May, there is a spike in alarm generated by mail, collaboration software, and project management tool, which is consistent with the month of November. In addition to this, in November, there is an increase in alarm volume generated by the CRM application. We can also observe that the HR suite of applications, that is the HRMS and the Recruit, experience a significant hike in alarm volume in June. To explore this further and correlate the root cause of these alarms, let's look at a detailed analysis of every planned and unplanned event that occurred during the months in year 2023 where there's a spike in alarm volume. This analysis reveals some very relevant insights. So the biannual server maintenance activities on application servers conducted in May as well as the month of November coincide with the spikes in alarm volume for mail, collaboration software, and project management tool. This correlation suggests that disruptions in application service availability and performance during maintenance activities reverberate across associated applications, triggering a surge in alarms. Similarly, for HR applications, that is HRMS and Recruit, the transfer of their compute to new VMs and servers in June corresponds with an increase in the number of alarms for these applications, underscoring the unavoidable downtime experienced during the server or VM migration process. The downtime extends to other applications such as CRM, which happens during the maintenance and replacement of its host server at the end of its life in November. Armed with these insights, NOC and IT leaders can proactively prepare for a deluge of non-critical alerts during planned maintenance activities. By developing alternate plans such as redistributing server loads or deploying temporary resources, you can mitigate the impact of IT downtime on critical operations. NOC managers can also anticipate infrastructure devices likely to be affected during scheduled maintenance activities, enabling them to make proactive decisions to maintain operational stability. With that, let's move to the second approach in mitigating issues that cause downtime. The second approach that we'll be discussing is mitigating mundane breaches that are caused due to irrelevant thresholds. Too often, thresholds are set based on generalized parameters rather than tailored to the specific needs of your IT environment. This can lead to a barrage of IT alerts triggered by expected behavior rather than genuine anomalies. Context is therefore key when it comes to alert management. It's not enough to rely solely on numerical thresholds curated based on predefined best practices. Instead, we must consider the broader context of your IT environment. This can include aspects like seasonal and geographical variations, as well as expected peak usage hours. To better understand this challenge and analyze the importance of enforcing contextual alerts, let's consider the case of Zilker, an imaginary paper and stationery manufacturing as well as supply firm. Zilker operates through multiple branches and regional headquarters distributed across states, with its corporate headquarters located in Buffalo, New York. One of Zilker's most heavily used applications, regardless of the branch size or location, is the order management application. This application helps the company manage sales and purchase orders, create packages and shipments, and send delivery updates in a single interface. The application experiences high traffic and usage, with people from multiple locations accessing it constantly. The number and frequency of usage increases with branch size. Zilker has deployed the order management application in its own on-premise environment. Based on their analysis of a few branches, the IT team at Zilker set a standard predefined threshold of 480 requests per minute for the application servers. This threshold is likely to consume around 90% of server's memory and is maintained across all branches, regional offices, as well as central headquarters. The analysis currently displayed on your screen shows that in locations like Palo Alto, Philadelphia, Chicago, etc., the request volume has far exceeded preset thresholds, leading to a high volume of alarms. The number of requests per minute, as well as the alarms generated, is highest in the corporate headquarters in Buffalo, New York. The MTBF, or the mean time between failures, is alarmingly high in these locations due to the barrage of alerts occupying the alert landscape. The obvious reason for this trend can be that higher order volumes and user traffic at regional headquarters and corporate HQ generate more requests as compared to the branch offices. But are all these alerts relevant and triggered to indicate the impending server overload? For that, we need to look at applications' memory utilization across locations. The memory utilization in all locations, as evidenced by the second analysis, is well within acceptable limits. This suggests that infrastructure at each branch is tailored to handle local request volume and footfall. Together, these two analyses provide critical insights for IT managers, such that the high MTBF and downtime at regional and corporate HQ locations are likely due to the false alarms triggered by irrelevant thresholds and not actual server overload. The solution in such scenarios is to avoid general static thresholds and have contextual thresholds that account for location and branch specific parameters to detect genuine anomalies and trigger only alerts that matter. So as we near the end of this webinar, it's evident that the journey towards uninterrupted IT operation requires a diligent, multifaceted approach fueled by data-driven insights. Through the course of the session, we established how intricate and complex nature of modern IT infrastructure demands the NOC teams to grow from a traditional reactive downtime mitigation approach to a proactive stance towards uptime optimization. Throughout the session, we unearthed three-step downtime mitigation framework and applied it to real-life NOC scenarios to understand how they can be leveraged to preempt, prepare for, and mitigate IT downtime, as well as reduce its catastrophic impact on IT operations. Let me just quickly summarize the 3 steps to efficient IT operations before we move forward. The first step that we looked at in our 3-step strategy is implementing preventive maintenance. Preventive maintenance is the foundation of a reliable IT infrastructure. By implementing robust maintenance plans, keeping tabs of the daily health of your infrastructure components to identify failure symptoms, and addressing potential issues proactively, you can prevent failures before they occur and reduce the downtime as well as minimize the MTBF for critical elements in your IT infrastructure. The second step in our 3-step strategy involves identifying and eliminating problematic devices. Eliminating hardware prone to downtime is imperative for preemptive interventions, averting costly outages and maintaining system reliability. By leveraging advanced analytics, you can pinpoint trouble spots within your infrastructure and take proactive action. And the final step that we looked at is analyzing patterns in alarms. As you know, alarms are your IT infrastructure's early warning system. But the sheer volume of alarms triggered on a daily basis can overwhelm NOC teams and eclipse critical issues that need immediate attention. By interpreting patterns and trends in alarms to identify common causes and mitigating false alarms generated by irrelevant or outdated thresholds, you can effectively navigate alarm noise and fortify your organization's IT infrastructure against unplanned downtimes. By following this 3-step structured approach, organizations can effectively minimize IT outages, significantly reduce mean time between failures, and ensure a more reliable IT infrastructure. The reports that we covered during this webinar were built using Analytics Plus, ManageEngine's AI-powered IT analytics solution, and using data spanning across multiple applications. Before we move on to the Q&A session, let me just quickly walk you through what you stand to gain from Analytics Plus. Beyond offering comprehensive analytical capabilities, Analytics Plus also provides out-of-the-box integrations with several IT applications. This includes various ManageEngine applications like Op Manager, Service Desk Plus, Endpoint Central, Application Manager, Site 24/7, Mobile Device Manager Plus, PAM 360, to name a few. The Advanced Analytics platform also provides pre-built analytics for various third-party IT applications such as Jira Software and ServiceNow. The primary benefit of these out-of-the-box integrations lies in the fact that they can be configured in minutes, post which you can access 300 plus pre-built reports and dashboards that are generated. So if you would like to attain a hands-on experience and apply this detailed analysis over your company's data, all you need to do is sign up or download the Analytics Plus free trial and set up the integration to access these insightful reports and dashboards. Moving on. In addition to offering out-of-the-box insights for major IT applications, Analytics Plus continuously strives to facilitate self-service on every level of its platform. A key player that facilitates this is our AI-driven analytics assistant, Zia. If you're just getting started with analytics and find BI tools to be daunting, well, Zia is your new best friend. All you have to do is strike up a conversation with Zia, either via voice or via text, and Zia will automatically generate insights required to further your analytics journey. While this removes the task of having to build a report yourself, understanding and breaking down the information displayed in a visualization can take up a lot of time. Well, we have got you covered even then. With Zia Insights, you can attain narrative, detailed interpretation of your analysis at the mere click of a button. This feature proves beneficial especially in cases where immediate action is crucial in putting out fires in your organization. You can leverage Zia's conversational prowess to dig deeper into your data to uncover hidden information and perform root cause analysis. And also, you can use the powerful forecasting engine in Analytics Plus to foresee future trends and modify your business strategies accordingly. Another beneficial and handy feature in Analytics Plus is our scenario analysis functionality. Using what-if analysis, you can execute powerful scenario analysis over your reports to visualize various outcomes based on a deciding factor. By understanding the business impact when changes occur ahead of time, you can adjust your strategies and achieve business objectives with ease. You can also set up threshold-based alerts for your reports and get notified via in-app alerts or via email. This saves you the trouble of having to recheck your reports manually every time and to avoid missing out on any critical business challenges that needs your immediate attention. It also is beneficial in notifying you of suspicious activities that occur within your IT environment. So that's a brief overview of the Analytics Plus application. Are you eager to explore more and elevate your IT analytics journey with Analytics Plus? Don't worry, you can get started right away with the application. Scan the QR code that is shown on our screen to access the 15-day free trial of Analytics Plus. That's all we have time for today, folks. But if you have any remaining questions or concerns about today's sessions or about the Analytics Plus, please feel free to email me at the email address that is being shown on your screen. Thank you very much for spending your valuable time with us today. Take care, everyone, and have a wonderful day ahead. Thank you.